Another similar situation, similar in many ways to the one we've just seen, is an object rolling down an incline. Now once more, you have a delta y. Okay, so you have a delta y vector. The object could roll down an incline like this. Now actually an incline wouldn't have a loop, but maybe it's a track like a roller coaster, and it does go around a loop and so forth. There's no assumption that the path from here to here is a straight line. So even if you're on an incline, the incline could have dips and rises. It could change its direction. The information you're given here is that the net force consists of a frictional force, gravitational force, and other forces. Well, the other force that's necessary here is the normal force. So your F net dot delta S, and I should have a dot in here, is frictional force times delta S plus the normal force times delta S plus the gravitational force times delta S, where again delta S and I can't say what I was about to say, okay. Really, if I want to talk about this, and I think it was stated this way, I've got to have F net average, frictional force average, normal force average, and gravitational force average. And what we mean by taking the average of a vector force is we do a line integral of the thing and divide by the distance and or divide by its instantaneous, well, I don't want to say it, I can't write it down. It involves line integrals, and I'd have to think of just how to word that because I'm already losing track of my words. Okay, so it involves line integrals. We can't really do it, so we're going to say we have the average frictional force, average normal force, average gravitational force, whatever that average actually means. It's relative to the directions of delta S and relative to distances and so forth. In any case, and I'm really going to stop this here because there are too many cases and I don't want to be misleading, so I'm going to stop for the moment, rethink this, and maybe change the notation a little. So we don't have contradictions. What I'm thinking is we need to be talking about the work done by the net force on small intervals where the delta S and the F net, where neither changes by very much. But let me rethink that. It almost seems that this problem has to be expressed in terms of integrals, but that wasn't the intent.